All right, just so everybody knows, for this project, we are going to use Entity Framework again. I know, but that was the decision. That's what they told us that we had to do. Is that the Oh no, it's not him. I'm just borrowing it. I'm you actually. Well, you from the future. But hey, I brought you some great news. And no, it's not the winning lottery numbers. No. Even better. See, what I've done is I'm here to give you some hope. You see, in the future, where I come from, Entity Framework has been rewritten. It doesn't suck anymore. Okay, go on. I'm listening. Look, I mean, we know Entity Framework has had its historical problems. Okay, it's there was a lot of inefficiency. There was a lot of overhead. It was easy to get started, but getting into the complex stuff took a while. Migrations didn't work very well. There were a lot of issues, just across the board. It wasn't thread safe. It's very, very focused on code first development. Well, actually, it still is. But not everything is perfect, of course. But so back in like around 2014, 2015, they were looking at rewriting .NET, the .NET framework. And so they figured that would be the perfect time to rewrite Entity Framework at the same time. So voila, in 2016, we had the first version of Entity Framework Core. Now, it was V1. It wasn't perfect. There were a lot of issues. But, it was off to a great start. And it has gone through several versions since then. And it's perfect now. Well, I mean, not perfect, but it's so much better than it is today. And there's a lot to look forward to. So let's talk first about what's missing. There were some things in Entity Framework that didn't get carried forward. The database first design is kind of there, but it's not really well supported. Entity SQL is gone completely. EDMX is gone completely. And the one thing that I kind of miss a little bit is the graphical editing model or graphical model editing. How you used to be able to design your database in a graphical designer in Visual Studio, and it would create your entities from that. Well, that's not there anymore, but pretty much everything else has been, redone and is there. And there's a whole bunch of new stuff like I was talking about. So, there's all kinds of things, and we'll kind of go through some of these as I talk to you for a little bit here, and just to let you know what you have to look forward to. But the first thing and the most important thing that we want to talk about is performance. I mean, we know Entity Framework right now, in the world that you're living in, isn't great. It's very slow. There's a lot of issues, but in the future, it's so much faster. It's just as fast as anything else that's out there, just about. So how does it compare? So let's look at some performance comparisons between Entity Framework and Entity Framework Core. And this is versus Entity Framework 6, and this is version 3.1 of Entity Framework Core, which is several versions ago, and it's gotten much faster since then. But as you can see, even after the first couple of iterations of Entity Framework Core, it was already 2 to 2.5 times faster than Entity Framework was for anything that it was doing. And that performance has gotten orders of magnitude faster since then. But even just back in 3.1, if you were comparing things like adds and updates and deletes, you can see that across the board the performance is much better than Entity Framework was, even its best version. But what about Dapper? That's the classic comparison. Everybody says, I'm going to use Dapper because Dapper is way faster than Entity Framework. Well, not anymore. If we're looking at retrieving a single record, you've got, the various methods that you would use with your link queries. But Dapper and Entity Framework are par for par. They're just about identical in performance. There's almost no difference between the two as far as select performance goes. The only method that is different is the single async. And that's because it retrieves 2 records, because, single is saying, okay, there should only be 1 record. So it does a top 2. And if it gets 2 records, it throws an error. So that's the only reason that the single async call is twice as long as any of the others. But par for par on everything else, Entity Framework Core and Dapper are just about identical. And this is version 9 of Entity Framework Core that we're talking about here. This is the newest version that's been out. And it's, dozens or hundreds of times faster than Entity Framework Core 3.1 was, or, Entity Framework 6. And that's just single record. But if we're looking at pulling in big batches of record, 14,000 at a time, you can see even then, Dapper, it's the exact same performance level as Entity Framework does. And in fact, in some of it, like the memory allocation, Entity Framework Core is even more efficient than Dapper. So it's pound for pound, on par with Dapper across every board, across every level. And of course, when we're looking at inserts as well, you can see that the performance here, Entity Framework Core and Dapper are right on with each other. In fact, Entity Framework Core is slightly faster in some cases. That's just something that you never saw in the past. Updates almost identical once again. Performance between Dapper and Entity Framework Core, and that was always the biggest comparison. Back in your day, that Dapper was faster, Dapper was more efficient. Dapper was so much better, but it's not anymore. Entity Framework Core is almost identical, and Entity Framework Core is going to use a little bit more memory. And that's just because of the support for things like change tracking that are built into Entity Framework that you don't have in Dapper. So it's the difference between the allocation and memory. But even so, it's really efficient. And so the argument comes down. These days the argument is what do I use when? And really, there really is no big difference between the two. There are a few cases where you might want to pick one or over the other. For instance, if you want, link query support out of the box, you can have that with Entity Framework Core, but you can use it with Dapper now too, because there are add-on libraries that you can use that let you use link queries with Dapper. Database versioning, Entity Framework Core is because it's code first, it's letting you do that much more easily with Entity Framework Core than you would with Dapper. And Entity Framework Core has a ton more features, which we're going to start going through here in a minute. So, when or why would I use Dapper? Well, still there's some times when you might want to use super high performance scenarios, and that just tiny bit of difference between Entity Framework Core and Dapper. If you're dealing with tens of thousands, hundreds of thousands, millions of records at a time, for that, those 1% scenarios, if that's what you need, then Dapper still gives you a slight edge. Performance-wise and memory-wise, but for the most part, it's a toss-up. You can do whatever it is that you want based on the features that you want to be able to support. And in this case, as I'll show you, Entity Framework Core has that edge over Dapper. It's just so much better when it comes to the features. So let's start talking about those features. And the first one is it's cross-platform. It's out of the box. It supports Windows. It supports Linux. It supports Mac. iOS, Android, WebOS, Arduino, Raspberry Pi, browsers. With WebAssembly, you can do .NET in the browser now. So .NET pretty much goes everywhere these days. There's almost nowhere that you can't run .NET, and so everywhere that .NET Core goes, so goes Entity Framework Core. And the next feature I want to talk about is property value conversions. These are scenarios where maybe you have data that's in one format in your .NET code, and of course, when it gets stored to the database, it gets stored in a different format. And the most common scenario for that is in enumerations, enums. Because in .NET you've got a text. If you're talking about characters in a sci-fi television series or movies or whatever it might be, a lot of them are in militaries, and militaries will have ranks. So maybe you've got a list of enumerations. It's general, admiral, captain, sergeant, ensign, whatever it might be. And that's how that's how you use it. That's how you work with it in your .NET code. But when that gets stored into a database, it gets turned into an integer. So, captain might be 1, admiral might be 2, sergeant might be 3. And if you're looking at the data in the database, then you've got to remember, okay, what does 1 mean? What does 2 mean? What does 3 mean? So, if you're doing queries directly against the data, it can be hard to remember what those enumerations stand for. Well, property value conversions lets you convert that data as you're saving it to the database and retrieving it back from the database. So that it can be in a completely different structure than what it would be by default. Let's say for those enumerations, you want to store them as the string values. I want it to say captain in my database. I want it to say admiral in my database. Well, with property value conversions, you can do that now. You don't have to store it as an integer by default. And what you do is in your model builder, use that .hasConversion function. And what you do is you pass in basically a pair of Lambda functions. Say, okay, when I'm saving it to the database, do this to my data and then store it that way. In this particular case, it's doing the a.toString. And so it's saying when I save it to the database, instead of storing it as an integer, I want you to convert it into a string and store it as a string. And then, the second Lambda function is the reverse. When it's coming back from the data store back into your .NET code, you're saying, okay, for this, I want to, parse that as an enumeration of type rank and store it back as, that enumeration in my data or in my .NET code. So, property value conversions make it really simple to store that data in your database in the same way that you have in your .NET code if you want. You can also, if you don't, you can do anything really, any type of conversion if you want to do some kind of business logic when you're storing it to the database or when you're bringing it back from the database. The property value conversions let you do that by default in the code, so you don't have to do anything manually. It makes your life so much better. The next thing I want to talk about is entity constructors. So what this does is it lets you have a constructor that Entity Framework will call by default based on the parameters that are being passed into that constructor. So in this particular example, I've got, a character class that has 4 properties in it: first name, last name, race, and rank. And, by default in the past, Entity Framework would call that public character constructor. And then it would set each of those values one at a time as it's being pulled in from the database. So, call the default constructor, create my character instance, and then it will assign the first name, and then it will assign the last name, then it will assign the rank, then it will assign the race or whatever. Well, with the entity constructors, what you can do is you can have additional constructors, and those might potentially be private or protected, accessibility. And in this particular case, I've got a private character constructor, and I've got those 3 properties: first name, last name, and race. And that will set those 3 properties. And what Entity Framework will do is if it finds a constructor like that, where the names of the parameters are almost identical matches to the names for the properties in the class, it'll call that constructor first. And then any properties that didn't get set by that, in this particular case would be rank, then it would set it the normal way that it would. So it would call that private constructor, passing in those 3 properties of first name, last name, and race, sets those values. And then after that, it'll say, okay, I still have rank to set, so it'll set rank, just like it normally would. Well, what this will let you do is have a constructor that perhaps only Entity Framework sees, that isn't, exposed to the public accessibility. And if you want to maybe do some kind of custom logic in that constructor, this lets you do that, so that you say, okay, when I'm doing a public, instantiation of a class in my .NET code, I'm calling that public constructor. But, maybe for Entity Framework, I want to be able to use this other constructor and do some kind of custom logic. And this lets you do that. Now, the restrictions are that those parameter names in the constructor have to match identically to the property names in your class. The only difference is that the properties have to be camel case, and the properties of your class have to be Pascal case, and the properties on the constructor have to be camel case. Other than that, they have to be the exact same spelling. Everything else has to be identical. Otherwise, Entity Framework won't recognize that constructor and use it. The other particular scenario that Entity Framework can't support is if any of your properties in your class are like navigation properties, you can't set those with a private constructor. It has to be at least protected or public. So that there are some restrictions that you have on what that constructor can be. But Entity Framework will always call the one that has the most matching parameters first, and then it will set any other properties. And it does this by default now. So if you have, two different constructors and one of them has, multiple properties that match, as I've talked about with the casing, Entity Framework will always call that constructor instead of the default constructor. So that's something to keep in mind. So there's a lot of scenarios, especially with older databases, where you may have a table that doesn't have a primary key defined. And in the past, that was very difficult to work with Entity Framework. Well, now Entity Framework has the keyless entity type. And what you do is you add that attribute keyless onto your class, your entity class. And now you can work with it in Entity Framework just like you would any other class entity. The biggest difference is that the table in the data store cannot have any primary keys defined, and it does not support change tracking like you would with anything else in Entity Framework. So if you keep those couple of things in mind, other than that, you can work with those keyless tables from your database just like you would any other table. That's a very handy thing sometimes, especially not so much nowadays, but there are a lot of legacy databases, in my experience, where they may have tables that have that kind of thing, or like a reference table that just has a bunch of plain data in it of some sort, random data. That's a scenario that's still fairly common these days. Now, we also have scenarios where a database can have, a table might have a primary key, but it may also have a unique constraint defined in another field in the database table. Well, now Entity Framework can use those as alternate keys, and it can work with entities of that type the same as it would with any other ID. And what you do is in your model builder, you define that dot has principal key value. And what that'll do is that'll give you full support for treating that like a key that has, it might have a foreign key reference from another database table. Which is something, in some database types that's supported. Well, now you can fully support that in your .NET code as well through Entity Framework using these alternate keys constructors. Another thing you might have is shadow state properties. So maybe there is a field in your database table that you don't want to be normally accessible to anything that references your class. But maybe you still need to be able to work with the data in that field at some point. So maybe, for instance, you have a medical application of some sort that has like PII information in it, and you are also allowing third parties to access your application through maybe an API or interface of some kind, and you want them to be able to access a lot of the data in that table, but say, that table also has like a social security number in it, and you don't want them to be able to access that or even know that field exists in that table. But maybe from your admin interface, you still need to be able to work with that data. Well, shadow state properties let you define something which does not exist in your entity class, but Entity Framework knows that field exists, and you can still work with it if you know that field exists also. So in this particular case, you're using like the DB context dot entry in this example that I've got on the screen here. The DB dot entry, and you're passing in your object instance. You're saying dot property last updated, and you can get the current value. You can set the current value, whatever it might be. You can also work with it, with like where statements using that. In the last example there, where I've got the dot order by, or I've got the X goes to EF dot property, and you pass in the property type, in this case, date time. And you're just passing in the reference and saying, okay, here's the field name that I want you to sort by. In this case, last updated. So If you know that that field exists and you set up Entity Framework with the model builder in the top example there, where you're defining the dot property, that's how you tell Entity Framework, hey, this property exists, but it's not part of the .NET class, but I still need to be able to work with it at times. So that if I know that it exists in my code, for again, back to my admin interface example, I can still work with it, but I don't want anything else that accesses my code and that particular entity to know that that field exists. So shadow state properties are a feature that lets you do that kind of thing now. The next thing is, a lot of times in your database, you may have values that are generated by the database. Well, in the past, there wasn't a good way for Entity Framework to identify what those fields were. But now there's this new annotation called database generated, and you can say, okay, this is a database, or this is a computed field, or whatever it might be. It's saying, okay, I don't want you to mess with this data in my .NET code. This is something that the database sets itself. So this particular annotation lets you define that as part of your entity in your .NET code, so that you can work with those fields and identify that those fields exist. So there's a little bit more to it, but you could have to check the documentation regarding that. This also makes it a bit easier to support database first design, which is something that you can do, and I'll talk a little bit more later on about it, but it's not something that's really supported well by Entity Framework Core. Global query filters. This one is huge. So they're another common use case. There are things like multi-tenancy or like soft deletes. So those are both use cases that you can support really well using global query filters. So let's say we have an example where we have a single API that supports multiple data or multiple websites. Maybe we've got fan sites for different sci-fi franchises. Maybe we've got a website for Babylon 5 and a website for Star Trek and a website for Star Wars. But I want to be able to use the exact same database or the exact same API and database on the back end to support all three of these websites. Well, what you can do is by using global query filters, you can maybe attach a service to your DB context and say, okay, as things are coming in from these various websites, my service is going to identify which website that request came from, and it's going to pass that value into my DB context when we're making our database queries. And then with the database or with the DB context in my model builder, what I can do is I can define something on the entity called .hasQueryFilter. So it's saying, okay, by default, universally, anytime that you're accessing this table or this entity, I want you to apply this filter to the queries. So even if that filter isn't part of the link query that comes in, add that onto it and apply that query filter by default. Well, this will let you use that kind of filtering so that you can support that multi-tenancy type functionality within your application, and it makes it really easy to do. And I'll show you here in a second that you can also bypass that when you need to. So say if you have yet another site that's an admin site niche where you need to be able to see all the data, well, you can easily set that up so that it will bypass that in your queries. I'll show you that here in just a second. Let's go on to the next one page here. This one shows, the top example there is also showing the soft delete example, which is fairly common in practice nowadays, where you can just set a flag and say, okay, by default, I want you to return data that isn't flagged as deleted. Now, the biggest thing to remember with a global query filter is that it can only be applied to entities that are at the top level of the hierarchy in your data structure. So let's say I have a character entity for characters for my different sci-fi franchises, and I've also got a seasons entity or a seasons table, which defines the various seasons of the TV series. Maybe I also have another table called episodes, where It has relationships to the seasons, obviously, but it also has relationship to the characters table. So saying, these characters are in this season, so on and so forth, or in this episode. So, if I have that kind of relationship where seasons has two different parents there, well, I can put the global query filter on the character table, and I put the global query filter on the seasons table, but I can't put the global query filter on the episodes table. So that's the biggest caveat to using the global query filters is that, if it's a table that's lower in the hierarchy, it has like parents in the hierarchy, you can't have the global query filters attached to those tables or those entities. So that's the biggest thing. And that's just a matter of, how you're structuring your data in the database. So just keep that in mind. And then anytime that you need to override that global query filter, then, for any link query that you're doing, you just add that .ignore query filters, and it will toss out any of the query filters that are defined. So if you need like an admin website or interface, then you just have it bypass that using the .ignore query filters, and it will toss those out. So, global query filters, I think, is one of the best things that Entity Framework Core has added as far as features go. So raw SQL. So now I know you're probably saying to yourself, if you work with Entity Framework, of course, in the past, you've been able to write raw SQL queries in Entity Framework for a very long time. And that's true. Even back in the original, quote unquote, classic Entity Framework, you were able to do raw SQL queries. So that's been around for a very long time. But what Entity Framework Core has done has taken it to the next level. So now you can mix and match your query, your raw SQL and your link queries. So, in this particular case, I've got my .from SQL doing my, raw SQL query, and then I'm adding some link statements. So .where, where the universe is Babylon 5, .include, so I can do my, include for my subtables and things like that. Entity Framework Core, is basically saying, okay, we had this great feature and it was fine and it worked, but we're taking it to the next level. And that's one of the best things. Another one of the best things I think that the Entity Framework Core has added on top of it. Another thing is statement batching. I'll just touch on this briefly. So, Entity Framework Core has made huge strides in figuring out how to group together various queries and various calls to the database. And say, okay, do I need to send these 40 at a time or 1,000 at a time or whatever it is to make it the most efficient calls? Well, that's great, and that continues to be iteratively better with each generation of Entity Framework Core. But in version 7 of Entity Framework Core, they added these a couple of new commands called .execute update and .execute delete, and of course they're async versions of those as well. So in these two examples here, so the top example, that's the classic way of doing Entity Framework calls to a database to get a bunch of data. Say you have 500 character records in your database table. Well, this is going to be 1,000 calls in Entity Framework because it's going to get each of those records one at a time, and it's going to update that record. So it's doing a select and an update for each record in that character table. Well, if you have a situation where you say, okay, I don't care what the existing state of that table is, I want you to execute this update for everything in that table, or you can of course add where clauses or whatever it might be. So the biggest difference between these two is they both do the exact same thing. These two examples here, but whereas the top example is 1,000 calls to the database, the bottom example is just one SQL statement, just one call to the database. It's saying, okay, I don't care about the change tracking. I don't care about the existing state, knowing what that is. Just make that update, make every character in that table a human. So by using this execute update functionality, and of course you obviously have to use it wisely and know when to use it and when not to. But by doing so, you can make your calls to the database even more efficient. And you don't have to write the raw SQL to do it. Another fantastic addition is DB context pooling. So typically, a DB context is a fairly lightweight thing in and of itself. It's the setup process, the instantiation of that DB context each time that it needs to be instantiated that is really where most of the resource hit comes. Because if you have a fairly complex DB context and it's doing a bunch of stuff and it's calling a bunch of reference things, every time that it gets instantiated, which, depending on how you include it, could be a lot. And that takes time, and it uses up memory, and it uses up a lot of performance out of your application. Well, DB context pooling, in effect, takes your instance of a DB context and it turns it into a singleton of sorts. Not exactly, but pretty close. So what it does is say, okay, when I'm done with this current instance of my DB context, instead of sending it off to the garbage collection, I'm going to keep it around in memory. I'm going to keep a reference to it. And the next time that a call comes in and I need an instance of my DB context, I'm going to reuse this existing instance of it instead of creating a new one. So there are a couple of things to keep in mind with this. And while this might not be a huge boost to performance or memory usage, if you're dealing with a large volume of database interactions, then every little bit helps. So by keeping these references around, you can bypass a lot of that and get that little edge, that little bit of performance boost that's add all these little bits add up over time and work to make your application a lot better. A couple of things to remember, as I said. One is by default, it will keep 1,024 instances around. It'll just, whenever it needs an instance, it'll grab an instance and use it. But remember, these instances still exist, and they were still set up from the previous or from their initial iteration. So if you have any kind of configuration in there, if you have any kind of session tracking or anything like that, if you've put any of that in your database context, your DB context, that information is still there from the previous runs. It doesn't get reset. It doesn't start over. It doesn't run the on configure again. So if you're doing things like multi-tenancy, if you're doing things like session tracking or anything like that, you have to be really careful how you implement those so that you don't screw it up by keeping a reference to something that you shouldn't have in that context. So as long as you're careful about how you structure it, how you set it up, then DB context pooling can be a really helpful thing as far as memory usage and that instantiation time. Another thing to remember is this is not the same thing as database connection pooling. So if you want to still use that as well, you need to implement that separately. Complex types. So this is something that came along in version 8. So here's an example where you've got your .NET code where I've got a customer and that customer has an address. Well, in your .NET code, you want to keep those separated. And in the past with Entity Framework, it would also keep those separate in the database. So you'd have a customer table and an address table, and they would have a parent-child relationship. Well, if you're going for proper, database normalization, if the relationship between those two sets of data is a one-to-one relationship, they really belong in the same table in the database. So what Entity Framework does is create this type called a complex type that lets you define that child instance or that child entity as a complex type, so that when it does go to the database, when it creates that database structure, what it will do is it'll take that address data and it'll keep that address data in the same table as the customer table. And you can also nest these complex types as well. I think up to like 4 or 5 deep. I don't remember exactly off the top of my head. So maybe your address also has like a geocoordinates class that has like a latitude and longitude. Well, in your .NET code, you want to keep address and your geocoordinates separate from your customer as separate entities. But, if it's a one-to-one relationship, when you go to the database, you really want to keep them together. So what it does when it creates that database structure is it's keeping them together in the same table. And it's basically for that subclass, that complex type, it's adding a prefix to it. So address_city. And if I had like the geocoordinates, I might be nested underneath the address, then it would be, in the database, it would be like address underscore geocoordinates underscore latitude and address underscore geocoordinates underscore longitude. So that kind of structure. So you're following proper database normalization if you care about that kind of thing, but you can also keep them as separate entities within your .NET code. So another feature is, or another thing that's common, rather, in .NET code is you might have a list of a primitive type. So a list of GUIDs, a list of ints, a list of floats. And again, in the past, when Entity Framework would store that into a database, it would create it as a child table. And you would have, in this particular case, I would have a customer table, and then I would have a wish list products table, and they would have a parent-child relationship. Well, for a list of a primitive type, it's really not a great way to store that data in the database. So by default now, Entity Framework will identify those lists of primitive types, and instead it will store them as an array in a JSON string table or a JSON string field in your database. So when this goes to the database, it will have that nvarchar max field of wishlist products, and those GUIDs will be stored as an array of strings in that field in the database table. And this was new in version 8 of Entity Framework Core, and it actually does this by default now. So this would be the default structure when it's creating that database schema if you're doing code first again. So this is a really handy way, and it keeps that in there. And then the way that it supports that and the way that you can query against it is by using OpenJSON, and that's the way that Entity Framework Core does it when it's converting that into SQL queries. Is it uses OpenJSON so you can query into those strings or into those arrays within that field in the database table. And of course, you can write link queries against them like you always used to. So, you might ask yourself the question, well, where is the benefit in this? Yeah, it makes it a little bit simpler, but it might also make it slightly harder to make that database call. If you're, having to go into the database and write that string or write that query yourself. Well, yes, it does. But where the big advantage comes is with things like in SQL Server, if that's your backend in this particular case. In the past, say you wanted to pass in an array of values or a list of values. And in this particular case, like the bottom example I have here, say I wanted to pass in these 4 first names and say, okay, give me every customer where the first name equals one of those 4 names. And you say, well, I've always been able to do that. And that's true, you could. But when Entity Framework in the past would convert that into a SQL string, it would create it as a static where clause. So it would write it as, where first name equals John, or where first name equals Jane, or first name equals Jim, or first name equals Jill. Well, if the values that you're passing in are different the next time, then SQL Server can't take advantage of cached query plans. It has to create a new query plan because the where clause is static. With this new primitive collections and using OpenJSON instead, where it can say where it will turn that into a parameterized SQL query and say where first name in, and then it has a variable that gets passed in, a parameter. Well, in that particular case, now SQL Server can reuse that cached query plan no matter what values you're passing in that array. There's not much visible advantage on the front end in your .NET code, but it makes a huge difference in your SQL code on the SQL Server side, so that it can take advantage of that cached query plan. By passing it in, as a parameter instead of passing it as a static where clause. So that's where the advantage of primitive collections really hits. Another thing that Entity Framework Core has added to is compiled queries. So obviously, in general, Entity Framework has always worked by compiling the SQL query at runtime. Well, what you can do now is you can create these compiled queries where you're saying, okay, instead of doing it in the just-in-time compiler at runtime, I want to compile this query ahead of time at build time. So when I'm doing my build, I will compile that query and include it in my .NET code. And the way you do that is just basically you're passing in a Lambda function in your EF using the ef.compile as query, or compile async query, sorry, in the example that you see here. And basically it pre-compiles that query. So it doesn't give you a huge performance boost. But again, as with a lot of things here, all these little bits add up. And if you can, if you have something that has a lot of interactions, a lot of little interactions, that compiled query can, the little advantage can add up over time. As we say, every little bit helps. So there are some other features that I want to call out, things like field mapping, nullable reference types, better support for that, better support for eager loading of derived types, wait for each. There's more data sources that are supported now, like Cosmos and in-memory. It's important to point out, while in-memory database structures are supported, they're not recommended for production use. So I think the best use case for that is if you wanted to, for your unit tests, if you wanted to use an actual data store instead of mocking, in-memory would let you do that fairly easily without having to mess with an actual, or having to mess with, a real database. And if for some reason you need to access Microsoft Access, that's in there and that's supported now. And of course, a bunch of support for JSON now through OpenJSON and other things. So there's a lot of great new features that are out there. So what you're telling me now is that there is hope. Oh, yeah, man. So much hope in the future. So, I promise it gets better. In my present, your future, everything is better with Entity Framework Core. So hang on to that hope and just keep plugging along. By the time you get to be my age, you'll find that Entity Framework is better in practically every way. Now, if you'll excuse me, I've really got to get this box back to where it belongs. Well, I guess I'm glad that he came around. I guess we'll have to put up with it for now.